To optimize API performance and scalability using an Enterprise Service Bus (ESB) API Manager, you can follow these best practices. 1. Caching. Implement caching mechanisms at various levels, such as the ESB API Manager and back-end services. Caching can significantly improve API performance by serving responses from cache instead of making repeated requests to the back end. Consider using techniques like content-based caching, where the cache key is based on the request parameters. 2. Load balancing. Distribute incoming API requests across multiple back-end servers using load balancers. Load balancing helps evenly distribute the traffic, improves response times, and increases overall system scalability. ESB API managers often provide built-in load balancing capabilities or integrate with external load balancers. 3. Connection pooling. Establish connection pooling to reuse existing connections instead of creating new connections for each API request. Connection pooling reduces connection establishment overhead and enhances performance. Most ESB API managers provide connection pooling mechanisms that can be configured for back-end service connections. 4. Rate limiting and throttling. Implement rate limiting and throttling policies to control the number of API requests processed per unit of time. This prevents abuse, ensures fair usage, and protects back-end services from being overwhelmed. The API Manager component of an ESB often offers rate limiting and throttling capabilities that can be configured based on various criteria, such as client, API, or subscription. 5. Caching at the edge. Utilize content delivery networks, CDNs, or edge caching mechanisms to cache API responses closer to the end users. This reduces latency and improves response times by serving cached content from edge servers located geographically closer to the consumers. 6. API analytics and monitoring. Monitor API performance using analytics and monitoring tools provided by the ESB API Manager. Gain insights into API usage patterns, identify bottlenecks, and track key performance metrics. Analyzing the data allows you to make informed decisions on optimizations and scalability improvements. 7. Horizontal scaling. Scale the ESB and back-end services horizontally by adding more instances or nodes. This distributes the load across multiple servers, improves fault tolerance, and enables handling higher traffic volumes. ESB API managers should support horizontal scalability by allowing the addition of more nodes or supporting clustering configurations. 8. Asynchronous processing. Consider implementing asynchronous processing for long-running or resource-intensive operations. By offloading such operations to background tasks or queues, the API can quickly respond to client requests and improve overall throughput. Asynchronous processing can be achieved using technologies like message queues, event-driven architectures, or task scheduling mechanisms. 9. Content compression. Enable compression of API responses to reduce the payload size transmitted over the network. Compression techniques like gzip can significantly reduce response times and bandwidth consumption, leading to improved performance. 10. Continuous performance testing. Regularly perform performance testing and benchmarking to identify performance bottlenecks, measure system capacity, and validate scalability improvements. This allows you to fine-tune configurations, optimize resource allocation, and ensure that the system meets performance requirements. By applying these techniques and leveraging the features of an ESB API Manager, you can optimize API performance, enhance scalability, and provide a better experience for API consumers.